Okay. As promised, we're going to do another example. This time, the sample size is 25. It's an odd number. So I have an odd number of values. And then if I do n plus 1, it becomes even. Divide by 2, I get a whole number, 13. So 26 over 2, 13. And here's the data here, 16, 23, 14, 62. Credit hours completed by students in a class of size 25. I added the rows, and then I added the sums of the rows together to get 951. So that means the mean, x bar, is going to be 951 over 25, like that. See what that is? 951 divided by 25. 38.04. Okay. And then we're going to find the median. First we'll make a graph stem plot here. This time I think we only go up to 100. Okay, 16, 23, 14, 62, 36, 42, 16, 40. That's those. 13, 15, 13, 107, 23, 40, 70, 32, 13 again, 45, 40 again, 22, 13, 36, 13, 98, 109, like that. And then we'll make the final stem plot. That's pretty long. 1, 2, 3, 4, 5 threes. And then a 4, and a 5, 2 sixes. 2, 3, 3, 2, 6, 6. 1, 2, 3, 2, 5, blank. 2, 0, blank, 8, 7, 9. All right, so it was 25 values. N plus 1 over 2 is 13. I'm going to count 13 places. Either way, from the bottom biggest to smallest, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks like that's it. And I guess I'll count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 32. Not too bad. And over here, we talk about when should you use mean and median, and how do they compare in size? They're supposed to both be values that are near the center of the data set in terms of how big the values are, a center value, typical middle kind of value. For nearly symmetric distributions, the mean and median are nearly the same. So if it was exactly symmetric, they'd be exactly the same. So you anticipate for symmetric distributions, the mean and median to be pretty much the same number. You say here 38 and 32 in this context of credit hours, going from 16 up to 100. That's off by 6, seems like a bit. For a skewed distribution, the mean is found on the side of the median corresponding to the direction of skewness. So if we look at our data set here, so if we were to make a histogram of that data set, which is basically what a stem and leaf plot gives you with the digits, you would see something that looks like this. Well, anyway, and so this apparently, if the center is probably here somewhere, well, we know where it is, it's 30. It's right between first and second bars. Yeah, pretty much there. So we see this one here is skewed right. And then here's the median. We would expect to find x bar on this side. So greater than the median. And sure enough, x bar is 38, the median is 32, so it's bigger than the median because the distribution is skewed to the right. So it says for skewed distribution, the mean is found on the side of the median corresponding to the direction of skewedness, skewed to the right, x bar is on the right-hand side. When are they used to represent center? Okay, the mean and median are both okay for symmetric distributions without outliers. So outliers also impact the mean in the same way skewness does, because you're adding extra values that are out of the side of the pattern, and either an extra large value would increase the value of the mean, or an extra small value that's way outside the pattern of values would decrease the value of the mean. So move it quite a bit, where the mean doesn't, the median is pretty much unaffected by skewness and outliers because it's finding the center value. So if I was to take one of these values here and make it a lot tinier, the median is going to stay in the same place, but the mean is going to change and get smaller. It says use the median with skewed distributions or if there are outliers. A compromise called the trim mean, which sometimes you'll see that as a feature of different kinds of stats programs. They'll let you compute a trim mean. It discards some fraction of the largest and smallest values, then finds the mean. So it's like a 10% trim mean will discard the 10% of the values that are largest. Sorry, a 10% trim mean, probably 10%, discards 10% of the values, the top 5%, the bottom 5%. I think that's how it does it if it's called the 10% trim mean, but the trim mean discards some fraction of the total values, that certain percent from the top, certain percent from the bottom, same percent. So that means if there's outliers, they'll get trimmed off, or if it's exceptionally skewed, some of the top and smallest X percent of the values get removed, and that takes away some of the skewness. And then after that's done, the software will compute the mean of what's left. So it's trying to combine features of mean and median by trimming and then finding the mean. So to get some kind of universal way of finding the center. Of course, there's no exactly universal center. But we'll be mostly looking at mean and median, which we will use for symmetric distributions, the mean or the median, and we'll use the median for skewed distributions. Made it through there, and see if we can't finish off this section with a bang.